So good morning guys, and this is the first session about the IO ports. And in this session, we are going to see about the various types of IOs and the examples of IO ports. So generally the IO is the input and output devices. The input and output devices that communicate to the controller, and the controller will communicate to the external world. So generally, to receive the bytes from the external peripherals for and reading them a letter using instruction executed on the processor, or to send the bytes to the external peripherals or devices or processor using the instruction executed on the processor. So based upon the instruction execution, we can communicate to the external world, or the external world can communicate to the controllers. So the port connect to the processor using the address decoder and the system buses. The processor uses the address of the port register for programming, and the port functions or modes are reading the port status for writing or reading bytes. So examples of the I/O ports are serial interface in 8051 and serial peripheral interface in 68HC11, and parallel peripheral interface, that is a parallel peripheral interface 8255, and the port 0, 1, 2, 3 in 8051 are termed as PA, PB and PC and etc. in 68HC11, and COM1 and COM2 port in Intel IBM PCs. The types of serial ports. So broadly, we are classifying the serial ports into five major categories: the synchronous serial input and synchronous serial output, the asynchronous serial UART input, asynchronous serial UART output, and also general I/O. We can term it as both input and also output. So, for example, a modem. The types of parallel ports is again classified as four major categories: the parallel port 1-bit input and parallel 1-bit output, the parallel port multi-bit input and parallel port multi-bit output. So based upon the number of bits, we are classifying these things. The first, we'll start with the serial port, synchronous serial input. So interprocess data transfer or reading CD or a hard disk audio input, video input, the dial tone and network input and transceiver input, scanner input, remote control input, serial I/O bus input, writing flash memory using SDIO, secure data. So usually we will term that as a SD card. This is a secure data association based card. And for example, and this is the data that is coming from the internal processor, and it will be sent to the serial input port. So along with the serial data transmission, that is a serial bit input that is coming out from the outside devices. That's the serial input devices. So along with the serial input, there is a clock pulses will be given. So this is the why we termed it as a synchronous. The data transfer between each and every bit will be having the equal phase difference. That is the time taken to transmit a single byte of instruction is equal to the for example, if you want to transfer the 16 MB of data, 16 different words will be behind the 60, and later we'll be seeing these timing differences. The synchronous serial input. The sender along with the serial bit also send the clock pulses, that is the serial clock, to the receiver port pin. The port synchronize the serial data input bits with the clock bits. Each bit in each byte as well as the each byte in the synchronization. The synchronize means separation by a constant interval or a phase difference. If a clock period is equal to t, then each byte at the port is received at the input in the period is equal to 8t. The bytes are received at a constant rate. Each bytes at the input port separate by 8t, and data transfer rate for the serial line bit is 1 by t bits per second. The serial data and clock pulse input. On the same input line, when the clock pulses either encode or modulates a serial data input bit suitably, the receiver detects the clock pulses and the receiver data bits after decoding and demodulating. On a separate input line, when a separate serial clock input is sent, the receiver detects a middle or a positive edge or a negative edge of the clock pulse. That whether the data input is 1 or 0, thus saves the bits in the 8-bit shift register. The processing element at the port saves the byte at the port register from where the microprocessor reads the byte. The master's output, slave input, and master input and slave output, the MOSI, MISO. The MOSI, when the serial clock is sent from the sender to the receiver and the slave is forced to synchronize the sent input from the master as well as per the input from the master clock. The master input and slave output, when the serial clock is sent to the sender from the receiver and the slave is forced to synchronize for this, sending the input to the master as per the master clock output. Synchronous serial input is used for inter-processor transfer, audio input, and streaming the data input. Synchronous serial output devices, the device serial bits and synchronization clock signals at the port output. The examples of the serial outputs are inter-processor data transfer. As like a serial input, the serial output will be the same application. The multiprocessor communication, writing to the CD or a hard disk, the audio input and output, video input bar output, dialer output, network devices output, remote TV control, transceiver output, and serial I/O bus, or writing to the flash memory using SDIO. So you will be having the output that is rising from the serial port, and along with that, we will be having the clock, which is an optional line. Each bit in each byte is sent in a synchronization with the clock. The byte sent at a constant rate. If the clock period is equal to t, then data transfer rate is 1 by t. The sender either sends the clock pulses at the serial clock pin or sends the serial data output and the clock pulses input through the same output line that the clock pulses either suitably modulate or encode the serial output bits. The synchronization serial output using shift register. The shift register is an intermediate register which acts like a buffer to store all the 8 bits. The processing element at the port sends the byte through the shift register at the port to where the microprocessor writes the byte. The synchronization serial output is used for the interprocessor transfer, audio output, and streaming the data outputs. The synchronous serial input and output. Half duplex serial I/O. The input and output at different time slots. This is a half duplex, which will have the different time slots for the transferring the data from in and out of the port. In the full duplex, you will be having a separate channel to transferring the data for input and also an output. Synchronous serial I/O. Each bit in each byte in synchronization at the port, and each bit in the each byte is in synchronization at the output with the master clock output. The bytes are sent or received at a constant rate. The IOs can be also on the same IO line when the input and output clock pulses either suitably modulate or encode the serial input and output respectively. If the clock period is equal to t, then the data transfer is 1 by t bits per second. The processing element at the port sends and receives the bytes at the port register to or from the where the microprocessor write or read the bytes. Asynchronous serial input. So this is the UART and like at the UART COM port. So UART is a universal asynchronous receiver and transmitter. So in this we'll be having the two devices, that is a data terminal equipment and data communicating equipment, which is termed as a serial port at the modem and UART COM port of a system. And this is the major two pins are the transmission pin and reception pin. The transmission pin of the UART is connected to the receive pin of the serial port, and the receive pin of the transmission pin of the serial port is connected to the receive pin terminal of the UART port. And there is another two pins, RTS and CTS, that is a ready to send and clear to send. So that is a another pin is a data set ready and the data carrier detect. The process start like this. The data carrier detect will send the pulse to the UART COM port and the data is being set ready to transfer. So if the data set ready is being received at the UART port, it's the data and the ready to send. The ready to send will send the pulse, and then clear to send is to acknowledge the pulse, and the data transmission will be started. So instead of using the clock pulses, we are using this kind of handshaking signal. So all integrated in the single embedded system. Asynchronous serial port line, that is an RxD, that is a receive data, does not receive the clock pulses or a clock information along with the bits. So each bit is received in the each byte at the fixed interval, but each received byte is not in synchronization. The bytes separated by the variable intervals or the phase differences. Asynchronous serial input, also called as UART input, if the serial input is according to the UART protocol. The example of the serial asynchronous input. So you will be following the certain protocols that is commonly termed as a UART protocol, which will have the certain rules in transferring the actual bytes. So asynchronous serial input is used for the keypad inputs and modem inputs in computer. The keypad controllers, the serial data in my keyboard controllers modem input character sends the input on the serial line, also called as UART, input while according to the UART mode. So you'll be having the actual 8-bit data along with that 8-bit data. You'll be having one start bit and the last it's end with a stop bit. So it may be in the format of 10-bit or 11-bit mode. So the 11th bit may be a optional bit, that is a p bit, which act as the optional. We can use or we cannot use. If you want to use, you can use, and if you don't want, you don't want to use this bit. The UART protocol serial line format. The starting point of the receiving the bit from the each byte is indicated by the line transition from 1 to 0 for a period of t. If the center shift clock period is equal to t, then the byte at the port is received at the input in period is equal to 10t or 11t due to the use of additional bits such as the start bit and the end of the each byte. The receiver detects a n bit at the interval of t from the middle of the starting bit, then the n is equal to 0, 1, and up to 10 or 11, and finds whether the data input is 1 or 0, and the slave the bit in an 8-bit shift register. The processing element at the port saves the byte at a port register from where the microprocessor read the byte. Asynchronous serial output. Asynchronous output serial port line is a TXD. Each bit in each byte transmit at a fixed interval, but each output byte is not in synchronization, separated by variable intervals or the phase difference. The minimum separation is one stop bit interval. The TX does not send the clock pulses along with this bit. The sender transmits the bytes at the minimum interval of n into t. The bits receiving start from the middle of the starting indicating bit. N is equal to 0, 1, 10 or 11, and the sender sends the bit through the 10 or 11 bit shift register. The processing element at the port sends the byte at a port register to where the microprocessor is to write the byte. The synchronous serial output is also called as a UART output if the serial output is according to a UART protocol. The example of the serial asynchronous output is the output from the modem or output from the printer, the output on the serial line, also called as a UART output when according to the UART. And this is again the classification of the half duplex and the full duplex mode. The half duplex mean at an instant the communication can be at one way on a bidirectional line. An example of the half duplex mode is a telephone communication on one telephone line. The talk can be only in the half duplex mode only. The full duplex means at an instant the communication can be in both the ways. An example of the full duplex asynchronous mode of communication is the communication between the modem and the computer. The RX and TX or the communication using SI using mode 1, 2, 3 in 8051. The parallel port single bit input. Examples of these things are parallel ports or completion for we can use it for the completion of the revolution of a wheel and achieving the preset pressure in the boiler and exceeding the upper limit of the permitted weight over the pane of electronic balance and presence of magnetic fields in the vicinity of within each of the robotic arm to the endpoint and filling of the liquid up to the fixed level. The parallel port output, that is a single bit. The PWM output, which varies with respect to time. The duty cycle will be varying in the PWM pulse, that is a pulse width modulation output from DAC, which controls the liquid level or temperature, pressure, and the speed of the angular position of the rotating shaft or a linear displacement of the object or a DC motor control. The pulse it acts like a pulse to the external circuit or a control signal to the external circuit. The parallel port multi-bit input. The ADC input from the liquid level measuring sensor or a temperature sensor or the pressure sensor or the speed sensor or a DC motor RPM sensor. Encoding Encoders input for the bits for the angular position of the rotating shaft or the linear displacement of an object. The parallel port output multi-bit. The LCD controller from the multi-line LCD display matrix unit in the cellular phone to the display on the screen. The phone number, time, messages, characters, and output or the pictogram weight image for display the screen or email or web page. print controller output, and stepper motor coil for driving bits. The parallel port input and output, that is a parallel port interface of 8255 and touchscreen in the mobile phones. And thank you. And this is the end of the session 4. And we will be seeing the next session about the PIC microcontroller. We'll be seeing soon. Thank you.